This is Chapter 5, Lesson 2, on page 172, how to prove that a quadrilateral must be a parallelogram. If you remember from Lesson 1, we learned that there are three properties of parallelograms. And those three properties are that opposite sides will always be congruent in a parallelogram, that opposite angles will be congruent in a parallelogram, and that the diagonals will bisect each other in a parallelogram. Well, these are going to serve as three ways to test whether or not a quadrilateral is definitely a parallelogram. And so if we take a look at a quadrilateral, and if we determine that we have two pairs of opposite sides that are congruent, then it's definitely a parallelogram. Or if we determine that we have two pairs of opposite and congruent angles, then the quadrilateral is definitely a parallelogram. Or if we discover that the two diagonals are definitely bisecting each other, then it's definitely a parallelogram. So if it passes any one of those tests, then this quadrilateral must be a parallelogram. There's a fourth test, and that is if I have one pair of sides that is both congruent and parallel, then I must have a parallelogram. One of the tests that we use is not do I have two pairs of parallel lines, because if I determine that I have two pairs of parallel lines, well then by definition it must be a parallelogram, because that's the very definition of a parallelogram. I would strongly encourage you to make sure you read page 172 thoroughly. Take a look at the four theorems that are on this page. Also look down at the bottom and read those ways of proving a quadrilateral parallelogram.